All right, so the last two plots for quantitative data that we're going to talk about are dot plots and stem and leaf plots. We've seen them both already, right? Dot plots we saw when we dealt with the smelling Parkinson's activity, and then we had a couple of examples, one with the World Cup goals scored per game in the group play in the activity last week. So a dot plot, literally, you just take, we were counting up number of siblings in this class, right? We just put a dot. Okay, everybody has 0, all the ones, and we'd make a dot plot. It's just an easy way, especially if we have discrete data to display things. It's not so great if we don't have discrete data, or if we're in that situation like we were here, right, where we have a lot of unique values. Then it isn't as great to see our distribution. But something like number of siblings, a dot plot would be awesome, right? Now, a stem and leaf plot, this is a little bit more useful if the unique values aren't an issue here, but we do want to have enough stems to make this worthwhile usually. So the one I had with the football data, I'll just go back to that and quickly use it as our example because I don't want to come up with a new one. We'll scroll all the way back. With the stem plot, this is just a way, like in this case, we wouldn't want to make a dot plot because 13, 14, we would have had a dot, all the way up to 23, a dot, 20. This is a stupid thing to look at, right? Like everything is going to have one dot until we get all the way back to 35, and then 35 will have 2 dots. It's not very exciting. But a stem plot essentially bends your data for you. In this case, that 13 and 14, they both start with the number 1, so they're going to end up in this little section of your stem plot with the stem of 1, and then 2, and then 3. So we can kind of see a little bit more of a shape going on to this distribution than we could in the other. So that's stem and leaf plots versus our dot plots. I know I'm going to make you dizzy scrolling. I should just stop the video. Like I said, they're quick to do by hand. They allow you to see the actual data values, which is one advantage they have over histograms, as we discussed in class. With a histogram, I don't know if the high score was 100 or 109 because it has this bin, and I don't know where the values fell within that bin. And these are both, the big disadvantage, which I didn't even put here, is that they're really only good. I don't know why this isn't here, because this is a huge disadvantage. They're only good for small data sets. You can imagine if you had 100 different values, you don't want to have all those things with dots. You don't want to have all those things listed out. So you really don't want, and especially in the day and age of big data, these are not necessarily a good go-to method. These are great for exploring quickly a tiny data set.